welcome back. In today's lesson, we're going to be learning about parallel circuits. And all parallel circuits are circuits with resistors running parallel to each other instead of in a series. So we can say it's a circuit divided into multiple pathways. So we'll say divided into two or more pathways. And all of these pathways are running parallel to each other. We can go ahead and draw an example of this so we can kind of see what's going on. So we'll draw ourselves a normal circuit, positive and negative, and we'll have a resistor somewhere in the middle, and then it connects at the end. And just like normal, the electrons start on one end, they travel through the resistor, and then they go to the other end. But instead of going this one path, we can, instead of taking a left here, let's say through this resistor, we have an alternate path for the electrons to take, also with a resistor passing through. And so let's give these some values. Let's say this first resistor, we'll call it resistor 1. Let's say it's 5 ohms. And let's say resistor 2 is also 5 ohms, just to keep it nice and simple. And lastly, let's give this a 20-volt power source. Now let's talk about what this means when we add a second resistor like this. The electrons can go one direction, traveling through resistor 1, or they can go an alternate direction, traveling through resistor 2. So we added a second resistor, but because of the way we added it, if you think about it, it actually improves the flow of electrons. Think of it like traffic. Giving you multiple options to drive home if everybody's driving the same route, giving people multiple routes improves the flow of traffic. So unlike in a series circuit, adding resistors in parallel actually adds paths to our circuit. And adding resistors in parallel, therefore, actually improves the flow of electrons. So we can just say adding resistors in parallel improves the overall current. And then we can go one step further by explaining why it improves the current, because it gives us two different flows of electron. We can have a flow of electrons, or current of electrons going through resistor 1, or we can have a current running through resistor 2. So actually, when we add resistors in parallel, we create separate paths, each with their own current. So we can say there is a separate current for each path. So let's go ahead and calculate these separate currents. Let's start with, we'll call it current 1. And current 1 is going to be the same formula for current as always. It's voltage divided by resistance. But since current 1 will be running through resistor 1, it's this first pathway as opposed to the second, we're going to say voltage divided by resistor 1. And we know what the voltage is. It's 20 volts. And we know what the resistor is. Resistor 1 is just 5 ohms. And so this is pretty simple math. We just say 20 divided by 5 is a current of 4 amps. And so current 2 will be the exact same. It's going to be the current flowing through resistor 2. So the formula is still voltage divided by resistance, but this time we'll say voltage is divided by resistance 2, I should say. And of course the voltage hasn't changed, but the resistor has to resistor 2. It just so happens that resistor 2 is the exact same resistance as resistor 1. That doesn't always have to happen, by the way. It just worked out that way this time, but we still get 20 divided by 5 is 4 amps. And so hopefully that was just way too easy, way too obvious. But looking at this, we have two separate currents. So my question to you is, in the circuit, what is the total current? Well, these two circuits will clearly, these two currents, these two separate pathways will combine to make a total circuit. In other words, current total equals the individual currents added up. So current 1 plus current 2, well, that's pretty simple. We know what current 1 is, and we know what current 2 is. It's just 4 amps plus 4 amps. Well, that's just simply 8 amps. So again, hopefully too easy, too obvious. Then we can move on and we can find, well, what is the resistance total in the circuit? How do these two separate resistors running in parallel add together? Well, the formula for resistance is voltage divided by current. And since it's the resistance total, we'll go ahead and use the current total on bottom. And of course, we know what both of these numbers are. The number on top is, of course, 20 volts. And the number on bottom is, of course, 8 amps. Now I'm bad at math, so I'll pull out my handy-dandy calculator, and I'll just say, well, what's 20 divided by 8? And we'll get a total resistance of 2.5 ohms. And this makes sense. Giving us two pathways of the same resistance essentially cuts the resistance from 5 ohms and 5 ohms to a total resistance of 2.5 ohms. So we could even actually redraw this circuit real quick to be an even simpler one. We could say that it is effectively the same as a circuit with just one resistor of 2.5 ohms. And of course, the voltage is the same in this hypothetical equivalent resistor. And the current, of course, doubles from one current of 4 amps and another current of 4 amps to a total current of 8 amps. So we could say that this circuit here is the same, essentially, as the other. And I'll go ahead and write current equals. But hopefully this is incredibly simple for you.